I have been working on a new project recently. As a part of this project, I needed to create a function that was performing some actions, returning multiple results. I was using memory pointers for it, so it was quite complicated. If you are not new to my channel, you know that in my videos I like explaining code line by line, and explaining this function in my project video would make it super long. So the idea is that I create a completely separate video in which I will explain to you what the custom function is, how you can create one, show you a few simple examples, and then move to the more complex one, similar to the one that I am doing for my new project video. Sounds interesting? If it is, stick around. Let's look at creating custom functions in Arduino code. Think of it as creating your own special command that Arduino can understand and follow. Here's a basic outline for creating a function. First, you decide whether your function will provide you with a result. If it will, you specify what type of result it will give back. If not, you simply use void. Next, you choose a name for your function. This name acts like a unique label for your command. Within the parentheses, you list the values your function needs to work with. These are the input parameters. Each parameter has a data type to let Arduino know what kind of data to expect. Inside the function, you define the actions you want it to carry out. If your function is designed to produce a result, you use the return keyword followed by the result. Let's look at the basic example of an Arduino function that doesn't return any values. This function works with two integer numbers, adding them together to produce a sum. We declare these two values and then create a function called addNumbers, which takes the two integer values as inputs but doesn't give back any output. Inside the function, we simply show the result of adding these two values on the serial monitor. Inside the setup function, we initialize the serial monitor and execute the function we created earlier, passing to it values stored in variables a and b. When we run this code, a proper value is displayed on the screen. It's important to note that the function doesn't actually return this value. It merely displays the data on the monitor for us to see. Sometimes you want the function to give you a value in return. So let's make our example do just that. Once again, we start by declaring two integer values, a and b, along with a variable called add that will save the result. Now in the addNumber function, things change a bit. We don't use void anymore. Instead, we say that the function will give us back integer number. Within the function, we utilize the return keyword to send back the answer obtained by adding the two integer numbers that are given to the function as inputs. During setup, we initialize the serial monitor. After that, we execute our custom function and store the result in the add variable. Subsequently, we display the value stored in the add variable on the serial monitor. The way we did things may be a bit different, but the program's end result stays the same. But with this approach, we can only return one value. The function outline that we looked at does not allow us to define multiple outputs. So what do we do if we desperately need them? To demonstrate how we can do this, let's write another function called calculations that will have the same two integers as an input but will return two values, the sum of them and the multiplication of them. Before we start writing this function, let's discuss object pointers that we will need to be able to do this. Let's imagine this is Arduino SRAM memory. You see some of it being empty and also various objects allocated in it. Among them our integer values add and mul, which will hold the calculation results. When we put the symbol ampersand before a variable like here, we are not talking about the variable's value anymore. Instead, we are marking an address in Arduino's memory where that variable is stored. The special object is called a pointer. Let's do the same thing for mul variable. If you want to declare a pointer, you give it a name just like for any other object, and for its type, you use the original variable type but with the asterisks attached at the end. So in our case, we are declaring the addr_add pointer. This pointer will point to the memory address where the add integer value is stored. If we've got the pointer set up and we want to get the value of the variable it points to, we just use the pointer's name with the asterisks in front. In fact, using asterisk with the pointer's name works the same way as if we were directly talking about add or mul variables without any of that pointer stuff. Now that we know this, let's create our new function. We won't give back results in the usual way, so we start by saying void in the function definition. We are going to need 4 input parameters to work with. 2 integer numbers that we want to do the math with, and 2 pointers that show where we can save the answers. By using asterisks with the pointer names, we can directly write the answers of the addition and multiplication into the right memory spots. After we run the function, the add and mul variables will be filled with those answers. This is how the function gives us 2 results. To finish the code, we'll create the setup function where we open the serial monitor. Since we are showing more information now, let's add some descriptions to make it clear. We'll display 2 integer numbers that we'll be doing calculations with. Then we'll run our special function with all the input parameters that it needs. Finally, we'll show the values in the add and mul variables to check if the correct answers got filled in. And there you have it. The code seems to be working. So that was a lot of theory, but how am I going to use it in my code? My project is centered around creating a digital clock using the new Arduino Uno R4 Wi-Fi board. The specialized task that I needed to address was setting up the time each time I upload the code into the microcontroller. I decided to use a macro called timestamp, which when run at compilation returns a string that contains various details about the date and time. So subsequently, the function I developed is a parser that takes that generated text and deconstructs it into a distinct components like hour, minutes, day of the month, day of the week, year, etc. If you're interested to see how this function was implemented, I encourage you to watch the upcoming video about this digital clock. It is in the final draft stage right now and will be available shortly for my channel members. You also would be able to access through Patreon. Okay, so this is all for now. Tell me if you liked this video, and if you did, show your support by giving this video a thumbs up and subscribing. You can also support my channel by becoming a member or through Patreon or PayPal. Many people did, and I'm very thankful. I'll see you in my next video. Ciao!